Hi, in this lesson we look at solving quadratic equations, and we'll look at three methods for solving quadratics. There's two methods that you've seen before, which would be solving by using the quadratic formula, solving by factoring, and we're going to introduce a new idea called solving by completing the square. So to introduce this method, we'll first look at the equation x plus 1 squared minus 4 is equal to 0. So notice that I could expand x plus 1 squared and then solve by factoring, or I could expand it, write it in standard form, and then use the quadratic formula. But I assure you this equation is a little bit faster if we just isolate for x by looking at inverse operations. So first off, let's add 4 to both sides of this equation. If we do that, we get that x plus 1 squared is equal to positive 4. Now I can take the square root of both sides of the equation, and I get x plus 1 is equal to plus or minus the square root of 4, which is 2. So some of you might ask, why do we need to add the plus or minus symbol? And the reason that we do that is because there's two numbers that when I square, I get 4. So I can square negative 2 and get 4, or I can square positive 2 to get 4. So anytime that you take the square root of both sides of an equation, you have to add a plus or minus symbol. So next, let's go ahead and isolate for x. We get that x is equal to negative 1, where I subtract 1 from both sides of the equation. I get that x is equal to negative 1 plus or minus 2. So we end up getting two roots, one where x is equal to minus 3, and our other solution is that x is equal to positive 1. So you can see that when you have a quadratic written in this form, it's really easy to isolate for x, just using inverse operations. So let's introduce this idea called solving by completing the square. Well, if I have a quadratic equation in standard form, such as 2x squared plus 3x minus 1 is equal to 0, I can actually isolate for x by completing the square. So let's look at how to do that. Well, the first step in completing the square on a regular trinomial in standard form is to look at the quadratic term. So 2x squared is the quadratic term. And common factor, whatever coefficient is on the quadratic term, out of the quadratic term and the linear term. So 2 is the coefficient on the quadratic term. So I'm just going to common factor that out. And I'll get 2 times x squared plus 3 over 2x bracket minus 1 is equal to 0. So all that I've done here is I've just divided both of these two terms by 2, and I've common factored 2 out of these two terms. The next step in completing the square, and so really what I'm trying to do here is I'm trying to write in brackets, I'm trying to write this as a perfect square trinomial in brackets so that I can factor it and I can write it in the form that I had above. So the next step in creating a perfect square trinomial is to look at the linear term, which is this term inside the bracket, take half of that, square it, add it, and subtract it. So if I take half of 3 over 2, well, taking a half of something is the same thing as multiplying by a half. So I'll do 1/2 times 3 over 2 squared. Well, 1/2 times 3 over 2 is just 3 over 4. 3 over 4 squared is equal to 9 over 16. So I'm going to add 9 over 16, and then I'm going to subtract 9 over 16. So I get x squared plus 3 over 2x plus 9 over 16 minus 9 over 16, close bracket, minus 1 is equal to 0. So effectively what I did here is I didn't change the value of the left side of this equation because I added 9 over 16 and subtracted it, which is the same thing as just adding 0. So lastly, notice that here, amongst these three terms, this is a perfect square trinomial. These three terms factor to x plus 3 over 4 squared. And I've still got outside of these brackets, I've got this term minus 9 over 16 minus 1 is equal to 0. So all that I've done here is I just factored these three terms into a perfect square. To get rid of the brackets, these square brackets, all that I have to do is distribute 2 into the square brackets. If I distribute 2 into the square brackets, I get 2 times x plus 3 over 4 squared. I can multiply negative 9 over 16 by 2, and I get minus 9 over 8. And I still have this minus 1 term outside of the square brackets. And I'll get that that's equal to 0. Now I've got my equation written in a pretty convenient form, such that I can isolate for x. So if I continue on this path, I get 2 times x plus 3 over 4 squared. I can add negative 9 over 8 minus 1 is minus, let's see, minus 1 is negative 8 over 8. So this is minus 17 over 8, and that's equal to 0. Next I can do 2 times x plus 3 over 4 squared. I can add 17 over 8 to both sides of the equation, and I get that 2 times x plus 3 over 4 squared is equal to positive 17 over 8. I can divide both sides of this equation by 2, and I get that x plus 3 over 4 squared is equal to 17 over 16, because I just multiplied both sides of the equation by 1/2. Now I can take the square root of both sides of the equation, and I get that x plus 3 over 4 is equal to plus or minus the square root of 17 over 4. Because I took the square root of 17, and I can take the square root of the denominator as well. The square root of 16 is just 4. Lastly, to find my roots, I write this as x is equal to negative 3 over 4 plus or minus the square root of 17 over 4. So I get 2 roots here. I get one root. My first root is negative 3 plus root 17 all over 4. And my other root is x is equal to negative 3 minus root 17 over 4. And I can add or subtract the numerators here because I have a common denominator. So that's how I got negative 3 plus root 17 over 4 and negative 3 minus root 17 over 4. There's a common denominator between these two terms, so when I add negative 3 plus root 17 over 4, negative 3 over 4 plus root 17 over 4, you get negative 3 plus root 17 all over 4, because there's a common denominator between these two terms. So the next question, it says solve by factoring. So here we have 2x squared minus 13x plus 15 is equal to 0. We can solve this equation just by factoring it. I can use guess and check. So if I write this as the product of two binomials, I can guess that this term and this term have to multiply to this term, which is 2x squared. So I guess 2x and x. This term and this term have to multiply to positive 15, and then I have to get a middle term that's negative. So that tells me that I should have a negative here and a negative here. Let's try, we can try 3 and 5 multiply to positive 15. Or sorry, negative 3 and negative 5 multiply to positive 15. So we'll try 2x minus 3 and x minus 5 is equal to 0. Next we have to check the middle term. The middle term comes from multiplying negative 3x and then adding to that negative 5 times positive 2x. So negative 3x minus 10x is negative 13x, so I've factored correctly. Lastly, I just look at each of these factors and I say, what values of x make the left side of this equation equal to the right side of this equation? So 2x minus 3 is equal to 0 when x is equal to 3 over 2. And x minus 5 is equal to 0 when x is equal to positive 5. And you can see why these values make the left side of the equation equal to 0, because if 2x minus 3 is equal to 0, I have 0 times some number, which makes the left side equal to the right side. If x is equal to 5, I have some number times 0, which is going to make the left side equal to the right side. So the solutions are x is equal to 3 over 2, and x is equal to 5. The last method that we're going to use to solve here is using the quadratic formula. I'm asked to solve 2x squared minus 13x plus 15 is equal to 0, and I'm told to do this using the quadratic formula. So recall that the quadratic formula says that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And here a is equal to 2, b is equal to negative 13, and c is equal to 15. So let's go ahead, we'll plug in those values into our quadratic formula, and we'll either get 2 solutions for x, 1 solution for x, or no solutions for x. But since we've already solved this equation, we can see that our roots should match when we solve by factoring. So b here is negative 13, so I'm going to do minus bracket negative 13 plus or minus the square root of negative 13 squared minus 4 times a, and a here is 2, times c, which is 15, all divided by 2a, and a is 2. So let's go ahead and we'll evaluate this now. Minus 13, well, that's just 13. We have to evaluate the this expression underneath the radical here. So 13 squared is 169, and 4 times 2 is 8. 8 times 15 is 120. So I have 169 minus 120, which is equal to 49. So we get 13 plus or minus the square root of 49 all over 4. Well, the square root of 49 is just 7, so I have 13 plus or minus 7 over 4. And that's equal to, well, I have 2 solutions for x. One is going to be when x is equal to 13 plus 7 over 4, which is 5. And the other solution is when I have 13 minus 7 over 4, which is, well, if we do 13 minus 7, we get 6. So we'd get 6 over 4, which is also just equal to 3 over 2. So the two roots are 5 and positive 3 over 2, and that should match when we solve by factoring, and it does. So in the next video, we'll look at how to tell how many roots a quadratic equation is going to have based on by looking at what's called the discriminant of the quadratic formula. That concludes this video, and we'll see you in the next lesson.